Please explain why Lamarck's theory of evolution does not accurately explain the evolution of the giraffe's long neck. What did Lamarck get wrong? Acquired traits aren't heritable. Good. If you acquire a trait, you're not going to just pass it down to the next generation. How does natural selection explain the evolution of giraffe's long neck? Somebody besides Isabel.
So the giraffes are short
Peter.
necks.
There's pre-existing variation in giraffes before there's selective pressure for long necks, and those that didn't have a long neck died, and those that did pass on their genes to long necks, and over time grew, because the selective pressure grew shorter.
Excellent. It starts with variation. So the big thing that one of the ways you could look at the difference between Lamarck and Darwin is that Lamarck was focused on individuals and how an individual would adapt, and that would go down from generation to generation, whereas Darwin focused on the population, right? So when we say that giraffes have long necks, we're talking about in the aggregate, the population of giraffes. The average giraffe has a long neck. Darwin was thinking about how that average would change over time, whereas Lamarck was thinking about how individuals changed over time, okay? All right, so the following scenario, be sure to show your work. By the way, you didn't need a calculator to do this. Having a calculator, I think, helped. There you go. What's that?
0.475 squared.
0.475 squared. Yeah, again,
I don't know.
you guys.
I don't even think I am.
I just call it 0.5 and square that, right? And you know, come up with 0.25.
Well,
we didn't
I
know that.
disagree.
So you guys, I should have brought this up before. You guys were getting a little too hung up on the number of decimal places. Like it's not. Anyway, it worked out okay. It worked out fine. What? What's P? What's P?
0.75.
0.75?
0.475.
0.475, there you go. Q? Good. Expected genotype of RR? Good. SS? It's fine. RS? Good. Observed frequencies? Good. SS, 0.5 and point. All right. Now the real question. I go. Is this population Hardy-Weinberg equilibrium?
No.
Why not? How do you know it's not? Elena?
Because the expected is not equal to the observed.
Because the expected is not equal to the observed. Excellent. Findings of the following microevolutionary processing, please give one example we covered in class. Gene flow. Gene flow is another term for migration, basically migration. What was the example we talked about in class? Or just one, you didn't have to pick one from class, but. Europeans, yep. Coming to North and South America. Good. Genetic drift. This is random fluctuations. Good. Random fluctuations in the genes, in the gene pool. Example, bottlenecks. Yep, population bottlenecks. Example of that. Good. Sexual selection.
Random mating.
It's non-random mating, right? Preferential mating based upon phenotype. An example of that. What's that? Oh, the long-tailed bird, the widow bird. Yep. That was a good one, yep. How can disruptive selection lead to speciation? Can you speak up? I can't hear you. Okay. So what happens is the trait, the selected for the extremes, over time, they become so different that they're no longer able to, what defines the moment of speciation? Reproduce and form fertile offspring, right? Exactly. Either they like literally can't, physiologically can't, or they choose not to. Why is radiometric dating so valuable in determining the age of fossils? What's so special about radiometric dating? It is not influenced by the environment because it's a process that happens in the nucleus of the atom. Good. Why does sexual selection usually have a greater effect on the fitness of males than of females? What's that? Sperm are not invaluable. Invaluable is one of those words that doesn't make any sense. Right, worthless. Yeah, sperm is cheap, eggs are expensive. Females have to invest a lot of energy into eggs / offspring, therefore it's in their best interest to be very choosy in selecting their mate. Based on what we learned about natural selection, why should you always take all of your antibiotics? This one tripped a lot of people up, a little bit. Why should you always take all your antibiotics? So let's go through natural selection. So for natural selection to occur, what is the first thing it has to have in the population? There must be no, variation. Has to be variation in that population, okay? Variation for a given trait. What's the trait we're interested in here? Ah, right, resistance to antibiotics, okay? So there's variation within that population. When you first take your antibiotics, you kill off, let's just say, the weak ones, right? The ones that are easiest to kill. In order to get all of them, sorry, let's back up for a second. If you stop there, what's left behind? Strong ones, right? Which will then reproduce and pass that on to the next generation, which will then have stronger, the population will actually get stronger over time. It's not that they become resistant. It already exists in the population. You're just selecting for that resistance. Okay? All right, good. Please explain. Okay, so this question, you guys gotta read a little more carefully. Please explain how a sympatric speciation event might occur. Be sure to include the reproductive isolation mechanism and the means for genetic divergence, right? So just talking about one example. Like you guys just like listed all this shit. I'm like, read the question. A speciation event, right? The problem then became you wrote so much down, you ran out of room and you forgot to write down the means for genetic divergence. What are the different mechanisms of genetic divergence? There are 5 we talked about. They are mutation, genetic drift, gene flow, and sexual selection. That's what creates the genetic divergence, because those are the microevolutionary forces, and evolution is what? What's the definition of evolution? Change in the genetic constitution of a population, right? So it's not enough just to get reproductive isolation. What then has to happen? Genetic divergence. You have to, the forces of microevolution move those now separate populations apart. Okay, please draw a cladogram based on the following chart. Most people did this pretty well. Some of your cladograms look really weird though. Oh, so this was a problem some people made. They wrote 1 down here, and then said it was lost over here. Not the most parsimonious explanation. What's a more parsimonious explanation? That 1 evolved there. 4, 3, A, B, C. All right, last question. In the article, Mammals Caused by Disease, Kate Wong proposed a new phylogeny. Please draw the phylogeny. You had to include the cetaceans, mesonychids, hippopotamus, and artiodactyls. Some of you included the trait. You didn't have to include the trait. But you did, that's cool. Why is this hypothesis controversial? We were talking about this in class. Why is it controversial? It's not very parsimonious, right? Exactly. Because the problem is that Problem is that ankle bone, the astragalus, evolved here, but then it had to get lost here. Right, so that's 2 evolutionary steps. Makes, according to parsimony, it'd be better to have the cetacean out here. But that's not what the DNA suggests, so. What trumps parsimony?
Data.
Data. Fact. Okay. All right, good job. Oh. Do other people want 5 minutes to look over the test before you move on? Or is that just an individual? Oh, why do you need 5? I've never had a student ask before. I've never had a student ask that before.
I just wanna ask a question.
Right now? Has to be right now?
No, it doesn't, but I'm leaving early.
Oh, you're leaving early. But you're leaving at what time? Well, we're gonna have a break, I think. Yeah. All right, good job.